In this problem, we're asked to match the equations of the rational functions with one of the graphs on the right. This type of problem is a nice way to test to see if we understand the properties of the graph of a rational function based upon the equation. So looking at A, notice how the degree of the numerator is 2 and the degree of the denominator is 1. So there are a couple things we should recognize. First, if the degree of the numerator is higher than the degree of the denominator, there are no horizontal asymptotes. But also, if the degree of the numerator is 1 degree higher than the degree of the denominator, then there's a slant asymptote. And of course, if there's a slant asymptote, there would not be a horizontal asymptote. And notice also we'd have a vertical asymptote at x equals b. Looking at our graphs, this is the only graph that has a slant asymptote and a vertical asymptote, and of course no horizontal asymptote. So this would have to be the graph of equation A. Now let's take a look at equation B. Notice the degree of the numerator is degree 2, and so is the degree of the denominator. When the numerator and denominator have the same degree, the horizontal asymptote is the ratio of the leading coefficients. So this has leading coefficient of 1, and so does this. So this function has a horizontal asymptote of y equals 1. It also has a vertical asymptote at x equals b. But also notice, for any value of x, the y value will never be negative because we're squaring both the numerator and denominator, which means the y values, or function values, will always be greater than or equal to 0. So let's take a look at our graphs. This is the only graph here where the y values are either on or above the x-axis, which means the function values are greater than or equal to 0. It also has a vertical asymptote and also a horizontal asymptote of y equals 1, which means this graph matches equation B. Now let's take a look at equation C. The degree of the numerator is degree 1, the degree of the denominator is degree 2, and since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote would be y equals 0, and we have a vertical asymptote at x equals b. There's only two graphs left. Notice this graph here does have a horizontal asymptote of y equals 0, which would be the x-axis. It also has a vertical asymptote. The horizontal asymptote of this graph here is not y equals 0. So this would have to be the graph of equation C. Of course, this will be the graph of equation D, but let's see why. First, notice how the degree of the numerator and denominator are both 1, which means the horizontal asymptote would be y equals 1 divided by 1, or y equals 1. And it has a vertical asymptote of x equals b. And this is the form of the type of rational function we're used to working with. So this graph here should look familiar. This would have to be equation D, because we have a horizontal asymptote of y equals 1 and a vertical asymptote. Okay, I hope you found this helpful.